Hey there! So let's say you have your data warehouse created using SQL Dedicated Pool. Great! You managed all this workload stuff, distributions, partitioning, accesses, and everything is working just fine. But then you start thinking, alright, but do I really need this additional layer after our data lake, which stores a copy of our data? Maybe you would like to go into this newer approach, the Lakehouse one, when we don't have this additional layer. And is it possible with Synapse? And the answer is yes. So we can use Serverless SQL Pool to achieve this. And that's the topic for today. So let's get started. All right. So today we're gonna focus on the last component of Synapse that I would like to talk about. So let's start with summarizing what kind of capabilities in Synapse we've covered so far. All right, so we've got Synapse Analytics. And you know at this point that Synapse, well, it is just this umbrella that combines multiple sub-services under the same service, under the same hood. And what we know already that exists in Synapse are, for example, pipelines. So we've got pipelines, which is basically the same as Data Factory. And pipelines, well, they can be used to orchestrate the whole processing or to just ingest the data. That's the place where they fit very well. Also, as a part of pipelines, we know that we've got data flows. The same stuff as in case of Data Factory. Data flows. And data flows, they can be used to transform our data in a visual way without writing any code. So that was the first component. Then we know that, all right, data flows are maybe fine for data transformations, but if you would like to have more control over the stuff that is happening in your processing, then data flows, well, they don't give you this control. So you want to create your own code. And the way to do this is to use Spark pools. Spark pools, and then write your notebooks. And basically this component of Synapse is something similar to Databricks, at least to Databricks clusters, because Databricks is something way more than just notebooks. Databricks. All right. So that was used for transformation purposes. And what we also know that exists in Synapse are SQL pools. And so far we learned about the first type of pool, which is dedicated. Dedicated. And dedicated SQL pool, well, it is the example of this good old traditional data warehousing, when we have a separate database that physically stores our data, to which we can connect using TSQL that has those regular tables. Good old database. But that's not everything that Synapse has to offer, because today I will talk about yet another flavor of SQL pools in Synapse, namely serverless. Because we've got two types of pools, SQL pools. So basically that's the whole landscape of Synapse that I want you to be aware of, those pipelines, Spark pools, and two types of SQL pools, dedicated and serverless ones. All right, but what is this serverless pool? Where does it fit? Why should we use it? So first of all, it is really a true serverless feature. So first of all, you don't have to create it. And please remember that in case of dedicated SQL pools, we have to first provision the whole Synapse workspace, and this doesn't change in case of serverless. But then inside our workspace, we had to explicitly create a dedicated SQL pool and choose the performance level, this DW100C slider, that determined many features like parallelism, number of concurrent queries, amount of memory that is available for processing, number of worker nodes, and obviously a price. In the case of serverless, we don't do this. It simply exists out of the box. Whenever we create Synapse Workspace, the serverless SQL pool is automatically created for us. So it just is there and it is ready to be used. Secondly, unlike Dedicated SQL Pool, for serverless, we pay for what we use. In the case of Dedicated, well, we pay for the uptime, and the price might be quite significant. You should remember that in the cheapest option, the one that I've been using, it was €1.5 per hour or something like this, in the cheapest tier. In the case of serverless, there is no price associated with uptime. No. In serverless, you pay for what you use. And basically you pay for amount of data that you processed. And the price is quite interesting because it is really cheap. So basically you pay $5 for 1 terabyte of processed data. So it might be really a cheap option. Now, but what this processed data means? So first of all, it is data that you read from your source, data that you write to your target location, and some intermediate results that are necessary during the processing. So actually, depending on the way you use serverless, it might be super cheap, or it might be not that cheap if you are querying a lot of data very often. But basically, I would position this service in the cheap area of services. At least it should be way cheaper than Dedicated. And obviously the architecture is completely different because in serverless, you forget about those distributions. They don't exist. Simply serverless is created for us. You don't care about the infrastructure. It uses a different architecture, so it is no longer this massively parallel processing MPP1. No, in the case of serverless, it is called distributed query processing. But basically it means that serverless scales automatically, depending on the workload. So you shouldn't even bother about those compute stuff that is used under the hood. You just use it and you pay based on the amount of data you're processing. All right, and that's great, but when should we use it? What are the use cases for serverless? And basically, well, there are 3 main use cases. So actually, let me write this down. Use cases for serverless. So we've got serverless. Let me just move whiteboard a bit. Serverless SQL Pool use cases. All right, and we've got 3 primary ones. So first of all, the one that I will start with is that you can use Serverless SQL Pool for ad hoc data exploration. And in a second, I will explain what I mean by this. So ad hoc data exploration. All right. So let's say that you're working with data and you received some CSV file or some Parquet file, and you just want to see what's inside. And now in the case of CSV file, that's easier because you can open a CSV even in Excel and it will format it more or less correctly. Even Notebook is able to open CSV file. But working with CSVs in notebooks, well, it is not the best user experience, especially if your file is big than Notepad or Notebook. Notepad will just crash. It will not be able to open it. It is even more difficult with Parquet files, which, well, they require specific software to be able to open this file. And you know that you could use this open source Parquet Viewer application, but it is a third-party tool and it doesn't offer that much functionalities. And actually, that's where Serverless SQL Pool can be very useful, because it allows you to very easily explore your data. So let me show you how it looks like. So let's jump into Azure portal. So that's my Synapse workspace. Let me open Synapse Studio. And in a second, I will show you how you can query your data. So let me go to the Data tab, to Linked Area. And here we've got, or I have several data lakes that are linked to my workspace. And I will focus on this one, ad-2_ls. So that's the one, that's our main data lake that we've been using so far. And on this data lake, I've got this curated container that contains data that is already transformed. And we've got this replicable directory. And for example, what we have is this minifix Synapse directory. I believe that's the minifix that were transformed using Synapse Spark. And they were just saved as Delta. Yeah, we can see that this is a Delta format because we've got Parquet files and this Delta log. All right, but let's say that I would like to see what's inside this Parquet file. I wouldn't be able to do this in Notepad, but here in Synapse, I just right-click on this file and then select New SQL Script and select top 100 rows. And let's see what happens. It generated a select statement that uses this super cool open row set function, and we'll get back to it in a second. And the thing to run it is to make sure to connect this time, connect to this serverless built-in pool, not to our dedicated one. No, we want to use serverless. So that's this one. And as you can see, it has this green check mark, which means that it is available. Basically, it should be always available for you, just waiting to be used. And you don't pay for this waiting time. You just pay for the time, for the amount of data that you process. So let me run this query and I will explain what it does. So take a look. I'm just using a regular select top 100 from SQL statement, which everyone knows how to use, right? And what is super cool is this open row set function that allows us to query data that lives externally compared to our serverless pool. In this case, I'm querying the data from my data lake. And the syntax is super easy. I just need to provide this bulk keyword, then provide a path to the file that I want to read, and finally indicate what is the format of the file that I want to read. And in this case, it is Parquet. And that's it. And take a look, the data was returned as a table. So now I can use full power of SQL syntax to query this data, filter it, aggregate, whatever I need to analyze the data. And take a look how easy it is to query Parquet file. You just right click on it, generate this dummy select statement, and that's it. It's working out of the box. I didn't have to bother with creating an SQL pool just to make this work. Great. But then you might think, all right, but you said that this curated minifix Synapse directory, it is a delta. And it is. And we know that in case of delta, we shouldn't focus on reading a specific file because maybe it is no longer a valid file. We have this delta log that maintains changes made in our data, and maybe based on the log we should read only the second file. So I don't want to read a specific file, I want to read the whole directory as delta, not as parquet. Is it possible? Yes, finally, in Serverless SQL Pool, we are able to read delta format, which is not possible in Dedicated SQL Pool. So how to make it work? Well, we just simply need to change the format of our data that we want to read. And if we try to run this, it will fail. It will fail because, well, it knows that in case of delta, we have to indicate not a specific file, but just a directory, because that's how we work with delta. You point to a directory that you want to read. So to make this work, I'll just remove the part that indicates a specific file, and I will read the entire minifix Synapse directory as delta. And it should work, hopefully. And then you will see that, all right, so the data is there, it was retrieved. And because, well, we can treat this result set as a view, as a table. So I could write my query on top of it. For example, let's see how many rows have been read from this minifix Synapse directory. And we've got 14,000, and that's the value that we've seen many times so far. So it is a proof that indeed we were able to read all of the data. So actually, let me start making some notes about this first use case. So we've got this open row set function. Super useful. And actually, it can read three types of files. So it can read CSVs. We will take a look at it in a second. It can read parquet that we saw, and it can read delta. Finally, a service that is able to read delta. And you should remember how many issues we had last time when I tried to copy data from a data lake that was saved as delta to Dedicated SQL Pool, because many services cannot understand delta and serverless can. Partially, unfortunately. Because, well, the support for delta is quite limited. So let me jump into documentation that tells how we can query delta lake, delta format, using serverless SQL pools in Synapse. And unfortunately, the first important statement here, this one, tells that, well, it can query only Delta Lake version 1.0. That is pretty old, to be honest. And starting from Delta Lake 1.2, well, serverless is not able to understand them. So you will not be able to make use of those new cool features that are introduced to newer versions of the Delta Lake. And you should remember that Delta Lake is this open source project that is developed and released independently from Databricks or Synapse. It is just a project on its own. And if we take a look at this Delta Lake version 1.0 or 101 actually, you see that it was released in 2022, so quite old version. And currently, the newest version is 4.0, which is in preview right now. So quite old version is only supported. And what Microsoft says explicitly is, hey guys, if you want to use newer versions of Delta, then switch to Microsoft Fabric. Sorry. Which should also give you a hint if Microsoft plans to invest a lot into Synapse. Here they say that go to Fabric, just forget about Synapse. All right, but at least there is this functionality to read Delta. So at least something for us. All right, so we know that it can read Parquet and Delta. So how about CSVs? So I should have some CSV file here somewhere. Yep, we've got this minifix CSV. That's again our minifix that were transformed and saved as, well, CSV. So let me run a script or generate a script that would query this file, and let's run it on our serverless SQL pool. And yes, I was able to read the file, but it doesn't look nice. So first of all, take a look at the column names. C1, C2, C3, and so on. And actual column names that are included in the file, they were treated as just regular columns. So no, we want to fix this. And the way to make this work is to include header row parameter equal to true. And this time, serverless SQL pool should treat the first row from the file as a header, and it should use those values, well, as column names. So let's see if that works. And yes, it works. Now this data looks better. So we've got those nice column names. All right, but how about data types? You know that CSV is a text file, so there is no data type, unlike in Parquet or Delta that store those metadata information. So basically, serverless SQL pool, in case of CSVs, it reads first 100 rows, and based on values, it tries to guess the schema. And usually it gets it right, but if not, then you might want to provide the schema explicitly. For example, you might say that, hey, I want to read maybe only this column, which is of date type, and maybe only number of parts, which is of integer type or whatever. And to make this work, you can again use this cool open row offset function, great function, and we'll just expand it with a statement called with, where we can provide the schema of our data. So let me move it aside a bit. And let's say that, well, I want to read only last modified date column, and I know it uses date and data type, and maybe this number of parts, which is int, and that's it. I want to skip all remaining columns. So let's see if this will work. And yes, take a look. We read, or we extracted only those two columns, and this time we know that their data types are set correctly, because we did this explicitly here in this with statement. So that's the way to make sure that the structure, that the schema of the data you read will be exactly as you want. Now, this open row set function is really cool. So the question is, why didn't we use it in Dedicated SQL Pool to read Delta files? Well, simply it's not supported in Dedicated. Sorry, it is available only in a serverless SQL Pool. So let's write this down. that unfortunately it is only in serverless. Then we know that, well, we can use this with part to define a schema of the data that we want to retrieve. All right, so is there anything else that is important about this open row set function? And actually there is. So let me show you the documentation, which is this one, how to use this open row set function. And here we've got a diagram that shows structure of some sample data lake. So we've got this web data directory, which contains some my data text file. And what is important is that it also contains some subdirectory with some data in it. And the thing about serverless and this open row set function is that by default it doesn't read subfolders. So if you would query it to read this web data directory, it will effectively read only this direct child, this direct file that lives inside this folder. It will ignore those subfolders and their children, unless you use this explicit syntax to read everything, which might surprise you, because personally I would expect it to read everything, just traverse the hierarchy, but it doesn't work this way. So actually, let's write this down, that this open row set function, it doesn't query subfolders by default. So doesn't query subfolders. All right, but that's fine. For this ad hoc data exploration, it is fine, because usually we would just explicitly indicate which file we want to analyze. And analyzing a file with SQL statement, as if it was a table, is super easy, especially if someone knows SQL. So this is a really good use case for serverless. And please remember that this serverless SQL pool, it is available out of the box. We didn't have to create it. It was instantly available. All right, so that was the first use case for serverless. The second one is to, well, use it to create this logical data warehouse. Logical data warehouse. Warehouse. Which is basically a lakehouse. So if you recall one of the first episodes when I was talking about different architectures, then what I mean here is this lakehouse one. So lakehouse, and that's the scenario when we don't want to have this additional relational data warehouse available after our data lake. No, because simply, well, we have data already available in a data lake. So what's the point in copying this data over to yet another layer? And if you would like to position this on our diagram, so it would look like this. So that's a diagram that we've been talking about in case of dedicated. So it shows those various options we have that we discussed so far. So we start with ingestion of various data sources, then we transform it on a data lake. So in the last layer of a data lake, we have our data transformed and stored as star schema using Delta format. And what we did previously was to load this data to Dedicated SQL Pool, physically copy it and store in those tables that later were queried by our users or by Power BI. And that's fine. In some cases, that is a good approach. So actually, we could query it in many ways. Now, what if we would like to modify it and don't want to have this additional physical layer and simply query the data from a data lake directly, but in a way that, well, we remember that not every data consumer can understand Delta. So we would need to have some kind of a translator in the middle that would, from one side, be able to talk TSQL from the consumer point of view, but also it could be able to connect to our data lake and read this Delta format. And that's where Serverless SQL Pool can be used. So here, let me draw it. So here we would use a Serverless SQL Pool. And how it would work? Well, it will again connect to our data lake that stores data as Delta format, but we will not copy the data physically. No. And in a second, I will explain what it means. And we would just expose it to our data consumers. All right, but well, I put those two SQL pools in the same place on our diagram. So what's the difference? And the difference is huge. So in the case of Dedicated, we copied the data physically from data lake to our SQL pool. In the case of Serverless, we don't copy this data. So basically, when someone queries our Serverless SQL pool using TSQL, this query is actually sent to the data lake transparently. So the data consumer is not even aware that the data lives somewhere else. Then data is read as Delta and returned on the fly to the customer. So from data consumer point of view, well, it speaks TSQL, the same language that every tool out there uses. And Serverless SQL Pool is used to translate those requests to those formats that are used to store the data. But data is not physically copied to SQL Pool. No, it exists only here in a single place. So that's the biggest difference in those two architectures. All right, so how to make this work? How to make sure that, well, we could use this logical data warehouse together with serverless. So let's go back to our use cases. And you should already have a clue what we could use. We know that serverless has this cool function called open-row-set that can be used, well, to query data that lives on a data lake that uses TSQL to query. So yes, open-row-set, that's the way to go, just to make this data available. Now, what if you would like to hide this complexity? Because here in those statements, you have to use this open-row-set function. You have to know those details about the location of the data, how it looks like. Well, super easy. Just create a view that has this open-row-set as a body, and then expose views to your data consumers, so they would just treat it as a regular view, and the logic would be hidden inside the database view. So super simple. So we could use just views. And finally, alright, so OpenRowSet is great for this ad hoc data exploration because we don't have to create any of those objects like we had to do in case of dedicated, like external data sources, external tables. But can we do this? And the answer is yes, you can still use external tables if you want to have a more structured approach to accessing your data. External tables, so this is still supported. So actually it means that, well, you can use two methods to connect your data lake, either OpenRowSet or by using external tables. So which one to choose when? And actually there is this nice article in the documentation that will be linked to the video description that compares those two methods and gives a high-level overview of them, so you will be able to see which one works better in your case. Alright, so let's create some of those logical data warehouse objects. So actually, I will use a sample that is provided in documentation. So there is this setup script that creates multiple objects. So let me simply copy it and let me run it on my Serverless SQL Pool. But I have to first make sure that I will create a new database that will work on the serverless pool. So I will use just create database statement like serverless test. Let me create this database. Alright, and then I will run this setup script in context of this newly created database. So that's the one. So one more time, I will connect to my serverless SQL pool, to my compute power, but within this SQL pool, I will use my newly created database, this serverless test. And from this setup script, I know that I want to remove a view that works with Cosmos DB because I don't have Cosmos DB in my environment and I know it will fail. Alright, so let me run this. It is creating some resources and let's see what happened. What are the outcomes of this script? So let me switch to workspace tab of our data. Let's see what databases we have available in our Synapse workspace. And right now it shows only this dedicated SQL pool that we've been using previously. So let me refresh the view. And this time we can see this newly created serverless test database. And what was created by the script are some views and external tables. So for example, we've got this CSV yellow taxi view, whatever it is. So actually, let's see what this view returns. Like select top 10 rows from CSV yellow taxi. Top 10 star. That should work. And basically, I just retrieved some data from some view. And me, as a data consumer, I don't know where this data is coming from. I don't care. I'm just querying this database. The same if we queried, for example, one of those external tables like Delta COVID. So let's do this. Select top 10 star from Delta COVID. Again, for me, for a data consumer, it is just an object inside a database that I'm querying. So let's see how those objects look like. So let me go back to our setup script and let's briefly go through it. So first of all, it removes some objects if they existed in the past. Cleanup part basically, so we can ignore this. And later on, what it does? Well, it creates some credentials that are used to get access to data lakes. And those data lakes to which those objects connect, these are not mine. It's not my data lake. It is some Microsoft data lake to which we've got to authenticate. And the way to do this is to use this shared access signature option. Then it creates some database schemas, and then it creates those external tables. So we know that we have to go with external data source, data formats, and so on. So here, for example, in the first external data source, you can see that it queries some storage account called SQL on-demand storage. And this is not mine. It is a Microsoft demo storage. Likewise, this Azure Open Storage account. Again, it is not mine. It is some storage account that exposes some New York taxi data that we'll be reading. And then the script creates some external file format. In this case, it is for CSVs with different properties. Then it creates a file format for, take a look, for Delta. And that's yet another difference between serverless and dedicated SQL Pool. So serverless can read Delta, but not only by this open row-set function, but also by using external tables by Polybase, which was not possible in case of dedicated SQL Pool. But here it works. And finally, well, they're creating some external tables using those objects created previously. So the CSV population table, it reaches some data stored on some Microsoft storage account. So this data doesn't live. It is not stored inside my serverless SQL pool. No, it is somewhere else. And my pool is just used to reference this data and read it whenever it is needed. And the same with views, which actually, take a look, they encapsulate the logic that uses this open row-set function. So again, those low-level details are hidden in a view definition. And for users, well, we just expose this CSV yellow taxi view. You can use it to read the data. But under the hood, they use open row-set function. And now, one additional cool thing about open row-set function, I know it is really cool function, is that we can use those wildcards, those stars. So basically, data on this SQL on-demand demo storage account, it is partitioned by year and months. And if you don't want to have to provide those values explicitly, you can use those asterisks that mean just year equals to anything, just like in various command line scripts. But what is even better is that later on you can reference those values by using a file path function, like it is done here in this view. And basically, file path 1 means just return the first wildcard that was used by the open row-set function. So in this case, it would be this value after the year, which we know is basically a year. That's why it is called, well, a year. The same, get me the second wildcard, which would be a month. And actually, if we take a look at the data returned by this parquet yellow taxi view, so let me copy this and let's run it like this, we should see those year and month values somewhere here. So these are the ones that were read based on a file path, on directories. So this is really cool. And they also use this with syntax to explicitly provide a schema of our data. So that's how it works. So basically, you can see that, well, by creating those either external tables or views with open row set logic, you can expose data to SQL queries, data that lives somewhere else, which is super cool. So it means that some data consumers would be able to read a data from a data lake via this serverless SQL pool. And actually, let's verify if I would be able to connect to read this data using Management Studio. I have it installed here. And let me try to connect. So let's just wait for it to start. And obviously I have to connect to some server. So what server name should I use? And the answer is simple. So let's go back to our Synapse workspace, to the overview blade. And here we've got two endpoints available. The first one on the top is the one that we used when we wanted to connect to dedicated SQL pools. The one below is basically the same. It has this on-demand suffix. So that's the one that we would use when we want to connect to serverless pools. So let me copy this and let me connect to this endpoint. And hopefully I will be able to connect. Obviously I have to authenticate. I'm using Entra authentication and I'm in. So take a look. I can see my serverless test database. And I can see those objects that are a part of this database, like those views and tables. So for example, let's query this CSV yellow taxi. So let's run this, and there it is. I was able to read the data. The same if I would like to read delta data by using Management Studio. It should also work. And yep, it works. So it is a proof that indeed we could use those serverless SQL pools as this intermediate layer between a data lake and data consumers without a need to physically copy the data. By the way, did you notice that we've got something more? We've got this Piotr T demo database here. So what is this? So basically, this is our database that we created when we were playing around with Spark SQL. So let me go back to Synapse. This Lake database, Piotr T demo. So that's the one that we see also in Management Studio. And this Lake database, well, this was a way to register our data that we were saving on a data lake, to register it in this Synapse catalog, so we could use SQL statements to refer to it. So it means that, well, if we see this database here, and the same you can see here in this database picker, that we can actually query those lake databases. So we can query the data that lives on a data lake that were created using Synapse Spark from a serverless SQL pool, which is again super nice. How it is called? Piotr T demo. Then we've got DBO schema and minifix delta, for example. And I should be able to query this from Serverless SQL Pool, and it works. So basically it means that Spark pools and serverless pools inside Synapse, they share the same metadata. And we can read those objects, those tables and databases created by Spark from Serverless SQL Pool, which is also nice, especially if you are using the same tool, Synapse Analytics, to perform all of the steps of our project. All right. So that was the second use case for serverless, this logical data warehouse. And the last use case that I would like to talk about is about, well, quick and simple transformations. So quick and simple transformations. All right. So let's say that the data that we have in a data lake, well, we would like to transform it a bit. Maybe they are not in a form that you would like to expose for some querying purposes. So how can we do this? Well, we know already at least some of capabilities. So we know that, for example, we could create views inside our serverless SQL pool. And inside a view, we can define a logic that would transform our data somehow. So that's the first way we can do this. And views, well, maybe they wouldn't work in case of super complex transformations, but for some simple ones, like some column selections, renaming, some data conversions, it would work. So views. Now, all right, but what if we have more complex transformations to be done? Cannot we just save the results of those transformations as a table inside serverless SQL pool? And the answer is no. And this is a big difference between serverless and dedicated. In a serverless SQL pool, there are no normal tables. They don't exist. So no normal tables. And by normal table, I mean just a table that we create in a regular way that stores data physically inside our database. And even if you expand the properties or the list of features inside this serverless SQL pool, this database, there is no place where those normal tables could be created. All we have to do are those external tables only that store data externally. So serverless, they cannot be used to persist your data, to store your data in a database. No, this feature is not available. So that's a big difference compared to a regular dedicated SQL pools, where we were able to create a table and save the data there. No, in a serverless, it doesn't exist. All right, so what if we would like to save some data? Let's say we have some view or some select statement and you would like to, well, persist the data somewhere. Is it possible? Yes, we can. We can use something called CETIS, which means create external table as select. So we can save the data, but not inside our database, but in a data lake. Basically, we can create external table. So this CETIS, create external table as select, simply means something as follows. So we've got some query inside our serverless SQL pool, that we would like to save its results somewhere. And this somewhere, in our case, well, it is a data lake. So that's the only place to persist the data on a data lake. And it would create an external table. Hence the name, create external table as select. And please do not confuse this with CTAS that we used in case of dedicated SQL pool. Because CTAS, it was create table as select, not external table, but regular table. And actually it was the opposite operation, because then what we had was like this. So we had a data in a data lake. We had external table defined, and what we wanted to do was to create a regular table and populate it with data based or data read from our data lake. So create table as select, and this select was select from our external table, which means select from a data lake. So different directions in those two cases. And now, so basically that's how serverless SQL pool differs from dedicated SQL pool. So you've got those three main use cases. And also you should remember that serverless, well, its setup is super easy because, well, it simply exists automatically. Whenever you have created this Synapse workspace, then this serverless SQL pool is up and running, is ready. For the dedicated one, you have to create it explicitly. On the other hand, when it comes to performance, this serverless pool, it will be usually slower because every time you query your data, it has to go to this data lake, read the data, maybe perform some operations during the select phase, and then return the results. In case of dedicated, we know that we've got those distributions that we can optimize for our queries. We can distribute the data, we can index it in a way that would speed up our queries. So basically, dedicated SQL pool will be probably faster to respond to your queries than serverless. All right, and basically that's it. So to summarize, serverless SQL pool is yet another flavor of SQL pools that we have available inside Synapse. It differs a lot from dedicated SQL pool. First of all, it is serverless, so it is available instantly. You don't have to provision it, and you pay for what you use. You pay for the amount of data that you processed. Now, it has those three main use cases. So it can be used for this ad hoc data exploration when you have some data in a data lake and you just want to start querying it just to see what's inside. And with serverless, it is super easy. Then you can use it to create this Lakehouse architecture when you don't need to store your data from a data lake in yet another copy in some database. No, with serverless, you can just read it using TSQL, and serverless will go to your data lake and get the data. But it will be probably slower than dedicated SQL pool. And finally, you can also use it to make some quick and some simple transformations that you would embed as a part of views or the CETAS statements. All right, and that's it for today. Thanks for watching and see you next time. Take care.